Hi guys, today I want to talk to you about graphing rational functions. So we've looked at expressions like this and how to add them or multiply them or solve equations. And the reason we have been dealing with all of those operations is so that we can better understand the functions themselves and how they look when they're graphed. So first I want to look at the graph of this function. Okay, so this is the function x minus 1 over x minus 3 times x plus 2. Okay, so what I want you to notice first of all is that this graph is kind of broken up into pieces and it happens to get really steep at certain places, right? So notice that around here at -2, the graph gets really steep at this piece. It also gets really, really steep at this piece right here. At x equals 3, the same thing is happening. There seems to be a break in the graph, and the graph is getting really steep as it gets closer to x equals 3 in both of these places. So why is this occurring, and what does that mean? So one thing to think about in terms of why specifically at -2 and 3, what's significant about those values? Well, if I look at my equation here, right, I have x minus 3 in the denominator, and I have x plus 2 in the denominator. Notice that both of those, if I set x minus 3 equal to 0, I would get x equals 3. And if I set x plus 2 equal to 0, I would get x equals -2, right? So if I'm looking at this function here, right, the values that make the denominator 0 are 3 and -2. Okay, and those happen to be the exact same places that this graph is getting really strange and having the break in the graph and getting really steep. Okay, specifically, if I look at what happens like in a table, if I plug in x values that get really close to -2. So notice when I plug in -2.5, I get -1. As I get closer, it goes to -6 and then -60 and -600 and -6,000, right? So what that's saying is as I'm getting closer to -2, my y values are getting really, really large, like infinitely large to the thousands. And if I kept getting even closer to 2, it would be a million. But when I get to exactly -2, it's undefined. There's no way to plug in -2 because you can't divide by 0. When I plug in numbers that are getting close to -2 from the other direction, like -1.9 and 99 and whatever, see these numbers are doing the same thing. They're getting infinitely large. That's why it's getting so steep. Okay? If I'm getting closer to 3, the same thing happens, right? As I get closer to a positive 3, my numbers get either infinitely large in the negative direction or infinitely large towards the positive direction. And that's what's causing this steepness in the graph. So if you haven't already, I'd like you to sketch this graph out and maybe make some comment about the steepness. Another way that you could say this is that as x gets closer to -2, the y is getting closer to infinity or the y is getting closer to -infinity, right? It's, in other words, as I get closer to that x value, the y's are getting really, really infinitely steep. And then the same thing is happening as x gets closer to 3, right? The y is either getting closer to infinity or -infinity because it's getting really, really steep like we're seeing here, okay? So this actually, we have a special name for this, and it's called an asymptote. Okay, so an asymptote is a line that a curve gets continually closer to as the curve approaches infinity or -infinity. Okay, so there's actually 3 different types of asymptotes. There's vertical, horizontal, and slant asymptotes. And we're going to really focus on vertical and horizontal. So what that means is that there's some vertical line that my curve gets really close to as it approaches infinity in the vertical direction. Okay, a horizontal asymptote would be a horizontal line that the curve is getting closer and closer to as it approaches infinity in the horizontal direction, right? Slant asymptotes, you can probably guess it's a slanted line that it approaches, but we're not going to be talking about that as much in this class. So what I want to really do is dive into vertical asymptotes and why they occur, where they occur, and exactly what happens on the graph. Okay, so let's go ahead and define vertical asymptote specifically. Okay, so a vertical asymptote occurs when this happens, when as x gets closer and closer to some value, I'll call it c, then the curve approaches infinity or negative infinity. So this can kind of happen in 4 different ways, just in terms of the direction, right? I could be coming from the left, and the graph gets closer and closer to x equals c, and the y gets closer to infinity. Or I could come from the left, and it goes down to negative infinity as I get closer. You can also come from the right, and the y would approach infinity, or come from the right and approach negative infinity. And sometimes a function has 2 of these things happen at the same time. It may approach the asymptote from the left and from the right at the same time. A horizontal asymptote is kind of the opposite. So if I have some horizontal line, right, as x goes to infinity or negative infinity, the curve gets closer and closer to some constant y equals k, some horizontal line. So remember, we call y equals a number is a horizontal line. And so the curve could, again, as x goes towards positive infinity, the y approaches that value k, and it could do it from above or from below. But either way, x is going to positive because I'm going to the right, and y gets closer and closer to this line. Of course, it can also, x can approach negative infinity, meaning it can approach the asymptote as it goes to the left, right? And it can do that from above and below. So if you see behavior that looks like any of these things, then you have a horizontal asymptote. And rational functions often have at least one or more of a vertical or a horizontal asymptote. And so let's go back to our original equation and talk about where vertical asymptotes occur. Okay, and it has to do with the denominator and the extraneous solution thing that we talked about in the past. Okay, so when do vertical asymptotes occur? They occur when at x values that make the denominator 0, okay, and do not, okay, they do not also make the top 0, okay, the numerator 0. So we have to be careful, and I'll talk about what happens if it makes both the denominator and the numerator 0 in a second. But the big key is when I look at a function, right, so I'm looking at this function here, we are looking for what values make the denominator 0. So in other words, just like we did yesterday or the day before, we're looking for essentially what would make this an extraneous solution if I was solving. It's the same idea. We know that we cannot divide by 0. It's not possible. So the values that make the bottom 0 make this function not exist. It's not possible to plug in 3 for x in this equation, because if I did, if I tried plugging in 3, it would say 3 minus 1 on top, and it would say 0 on the bottom, right? I can't do 2 divided by 0. It's not possible. This function does not exist. There is no point at x equals 3, and there's no point at x equals negative 2. And what happens instead is I have a vertical asymptote. Okay, so if I were graphing this, even if I know we've already seen it, but I would be able to say, oh, at x equals 3, there's going to be a vertical line that the graph gets really close to, but it's not going to touch. And at x equals negative 2, the same thing. Okay, and those are where my vertical asymptotes occur. So let's look at a couple more examples and just make sure that we understand. But also let me talk about that exception when what happens if it makes the denominator and the numerator equal 0. So what we call it when there's an x value that makes both the bottom and the top equal 0 is a hole. We say there's a hole in the graph. Okay, in other words, it'd be like saying, there's a common factor on the top and bottom. Okay, so anytime the same value makes the top and the bottom 0, there's a hole. If it only makes the bottom 0, and not the top like 3 and 2 did here, right? When I plugged in 3, I got 2 on the top, but 0 on the bottom. If I plug in -2, I get -3 on the bottom, or on the top, but 0 on the bottom. But when it makes both 0, we get a hole. Okay, so let's look at a couple examples right now. This first example, the first thing I want to do is set the bottom equal to 0. Set each factor equal to 0. So if I do that, I would get x minus 2 equals 0, which gives me x equals positive 2. And I would get x plus 1 equals 0, which would give me x equals negative 1. So the question is, which of these is a vertical asymptote and which is a hole? Well, now I go back to the top. If I plug x equals 2 into the top, it does not give me 0. So this is a vertical asymptote. This is a vertical asymptote. But x equals negative 1, if I were to plug that into the top, I would get 0 over 0, right? It does make both 0. So that means there's a hole. Okay, and we're going to look at the graphs in class and see the difference between what these two mean. But literally what it means is, if I were graphing this, I know that x equals 2, I should have a vertical asymptote. And once we learn what the rest of the graph is doing, what it will literally mean is that when I get over here to negative 1, whatever this graph might be doing, I'm just going to make this up, there's actually going to be a literal, just a hole in the graph, and it's going to keep going. Okay, so maybe you have something that looks like this. So that's what's going on. Let's look at a second example. So here, again, first thing's always the same. So if you want to write down a step here, the steps are set the bottom equal to 0 first, okay, and solve. So if I do that with this function, I would get, again, x minus 2 equals 0, which gives me x equals 2. I would also get x plus 4 equals 0, which gives me x equals negative 4. When I'm looking at the factors on the top, 2 and negative 4, neither one of them add plus 1 to be 0. So I would say these are both vertical asymptotes. Okay, so if I were starting the graph of this, we would have a vertical line at negative 4, and I would have a vertical line at 2, and I know that my graph's going to be approaching them. And I don't want to make this video too long, so we'll learn more about the details of that in class. So just to kind of wrap it up, I want to do 2 more examples. So here's one. If you want to pause it and try it, I'll give you a hint though. On the bottom, we need to factor it before I can find out what makes it 0. Here's a second example. If you want to try these 2, go ahead and pause. See if you can factor the bottom and figure out where there are vertical asymptotes and where there are holes. So I'm going to pause right now. And assuming you guys have done this, I'm going to work these 2 out for you. Okay, so the first things first, we want to look at what would factor on the bottom. So what multiplies to be 2 and adds to be 3, that would be x plus 2 and x plus 1. All right, so once I have it factored, the problem becomes easy. I'm going to set the bottom, each factor equal to 0. So I write x plus 2 equals 0, which gives me negative 2. And I'm going to write x plus 1 equals 0, which gives me negative 1. Once I do that, I look at the factor on the top. You can notice this factor x plus 3 is not the same as either of those, which already gives it away. But if I specifically plug it in, negative 1 plus 3 does not equal 0. If I plug this in, negative 2 plus 3 does not equal 0. So what does this mean? It means there's a vertical asymptote at x equals negative 2. And at x equals negative 1. There are no holes because it doesn't make the top and the bottom 0. Second one, again, we want to factor first. So we would have x minus 5 and x plus 3 on the bottom. When I set these equal to 0, I get x equals 5 and I get x equals negative 3. Positive 5 does make the top 0. So I would say there's a hole at x equals 5. Negative 3 is a vertical asymptote because it does not make the top 0. So that's what we need to know. I'm going to teach you the rule for horizontal asymptotes and then better idea of how to graph these things in class. But I hope that makes sense. Please, please, please come and ask questions and be prepared for class to learn some good stuff. Thanks for watching, guys.